2.3b is on real-world modeling of linear. So we're looking at everything we know about linear equations, but we're looking at it in the context of some real-world situations. Recall that our y-intercept is the starting value in a situation. So when we're thinking about our linear situations, our slope-intercept form, y equals mx plus b, our b is our starting point, our starting value. And then our m is our rate of change, how the situation changes. So, our first example, each member of the volleyball team would like to buy a sweatshirt. There's a setup fee of $10, and each sweatshirt costs $20 to make. So what are we talking about? We're talking about the cost of sweatshirts. All right. So if we define our variables, remember our equation is going to be in that slope-intercept form, y equals mx plus b. So our variables for our linear equation are x and y. So when we're defining these, we're not looking for a number. There are many numbers that x and y could be. We're looking for what it's representing, what thing, what noun. So remember we said our problem was talking about the money we're spending on sweatshirts. Right? So if I buy one sweatshirt, I'll have to spend $30. If I buy two sweatshirts, I'll have to spend $50. So my number of sweatshirts I buy decides how much money we have to spend on these. So x is my number of sweatshirts and y is the amount of money we're spending. So now we can go to our equation. Well, what are the values or the numbers that they gave us? They said we have a setup fee of $10 and for each sweatshirt we're paying $20. Okay, well, how many times do we have to pay the setup fee? We just have to pay that once. Right? That's where we start. We go to the company, we say, hey, can you make us some sweatshirts? And they say, sure, give us $10. So our $10 would be our starting value or our B. The $20 for each sweatshirt, well, that's saying if you buy one sweatshirt, we need $20, two sweatshirts, we need $40, three sweatshirts, we need $60, right? For each sweatshirt, we have to pay more. So our M, our rate of change, would be $20 because that's how the amount of money we're spending is changing based on each sweatshirt we buy. So if we put this all together, our equation is y equals 20x plus 10. We're going to do one more thing before we go to our table and our graph. We're going to state the domain and the range. So remember the domain is the possible x values. In this case, it would be sweatshirts. So what's the lowest number of sweatshirts I have to buy? 0. I don't have to buy any sweatshirts. So I could buy 0 sweatshirts, or I could buy 1 sweatshirt, or 2 sweatshirts. And I don't actually have a maximum, because it didn't say you can only buy this many. So as far as I know, I could buy as many sweatshirts as I can think of as possible. So my range, that's my y, that's my money. Okay, well, what do we start with? Well, we spent $10 to set this up. So even if nobody decides to buy a sweatshirt, we still spent that $10 to get everything going. Okay, so we spend $10 if we buy one sweatshirt. 10 plus 20 would be $30. If we buy two sweatshirts, that'd be $50. And then on, right? Because we don't know how many sweatshirts we're going to buy. We don't have a maximum. Notice that I wrote my domain and range in set notation because these are discrete, right? I can't buy half of a sweatshirt, all right? So when I'm looking at my table, I'm just putting my x and my y values. So I could buy 0 sweatshirts, and that would be $10. One sweatshirt, I'd have to pay a total of $30. Two sweatshirts, I'd have to pay a total of $50. Three sweatshirts, I'd have to pay a total of $70. 4 sweatshirts, I'd have to pay a total of $90. And notice that each time I just added 20. Okay, added 20 in that y column. And last but not least, we can do our graph. When we do our graph, we have to make sure, I'm going to zoom in on it, we have to make sure we are labeling it. So my x-axis, that would be labeled my number of sweatshirts, because x is representing our sweatshirts. Our y-axis would be the money, because y is representing the money. And then overall, our graph is talking about the cost of sweatshirts. So that's my title for my graph. Now for my x-axis, I'm just going to go by ones, right? because I'm buying one sweatshirt at a time. 5, 6, 7, 8, 9, 10, 11, 12. But ones won't really work for my amount of money, so I'm going to go by tens. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. And now we can graph. So even if I buy 0 sweatshirts, I still need to pay $10. When I buy one sweatshirt, I pay 30, 2 sweatshirts, I pay 50, 3, 70, 4 sweatshirts is 90, 5 sweatshirts would be $110, 6 sweatshirts would be $130, 7 sweatshirts would be $150. Okay, now I'm just going to leave it like this. I'm not going to draw a line because, again, this is discrete, which means that these are each individual values, right? I can't buy half a sweatshirt, so it wouldn't make any sense for me to connect my points because we can't actually have our x can't be between 0 and 1. It can't be between 3 and 4. We either bought 3 sweatshirts or we bought 4 sweatshirts, so we leave it separate like this. All right, and that's the cost of sweatshirts for our volleyball team. Let's look at a couple more examples. It'd be a good idea to pause the video and see if you can fill out any of this on your own. The current temperature of the water is 50 degrees Fahrenheit. You're heating the water on the stove, and the temperature is rising 20 degrees every minute. Well, what are we talking about? We're talking about the temperature every minute. So my x and y, right, we're talking about how the temperature is changing each minute. So x is going to represent my number of minutes, and y is going to represent the temperature. Okay. Now we want to write an equation. Well, remember we're going to write this in our slope-intercept form, y equals mx plus b. Where did our water start? It started at 50 degrees, right? So the current temperature is 50 degrees. So our starting point, B, would be 50 degrees. And then our slope, M, is how it's changing. So how is it changing every minute? Well, they told us it was rising. It was rising 20 degrees every minute. So rising means it's going up. So our M would be a positive 20. So our equation is y equals 20x plus 50. Now we can write our domains. Remember, our domain is our x, which means it's the number of minutes. Well, how many minutes can we do something for? We could do something for 0 minutes, right? And then technically there's not a maximum that we know of. So I can write this as an inequality because this is going to be continuous, right? Because time is technically continuous and so is temperature. So I'm going to write this as 0 is less than or equal to x. And then for our range, well, our lowest temperature is 50 because that's where we started, and then we don't know where it ends. So 50 is less than or equal to y. You could also write it with the variable first, x is greater than or equal to 0, or y is greater than or equal to 50. Well, now we can create a table of values for this. So here's my x, here's my y. 2, 3, 4, I'm going to create 5 points. So when x is 0, after 0 minutes, right, we just started keeping track, our temperature is 50 degrees. Well, 1 minute later, it rose 20 degrees, so that would be 70. 2 minutes later, it would rise another 20 degrees, so that would be 90. 3 minutes later, it would be 110. 4 minutes later would be 130. All right. Now we can graph this. So again, we want to label everything. I'm going to zoom in on my graph. So we're talking about the temperature of the water after each minute. So x would be my number of minutes. Here's x. And then y would be my temperature. Okay, well for x, again, when we're talking about minutes, it makes sense to say 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, right? I'm going to skip count for the rest of these, 14. But for my temperature, that doesn't really make sense because I can't get up to 130 on this graph if I count by ones. So, we started at 50. I could go by 10s or 20s. I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. All right, well now I can graph. So at 0 minutes, the temperature of the water was 50 degrees. After 2 minutes, the temperature of the water was 70 degrees. After 3 minutes, it was 100, I skipped one. After 2 minutes, it was 90 degrees. After 3 minutes, 110. After 4 minutes, 130. After 5 minutes, 150. Now remember we said temperature and time are both continuous, so we can connect these dots because we could figure out what the temperature is after a minute and a half if we wanted to. All right, let's do one more. Again, it'd be a good idea to pause and see if you can solve this for yourself. Sarah has $100 in her savings account but is spending $5 each day on coffee. Well, what are we talking about? We're talking about the amount of money we're spending on coffee. So the amount of money we have depends on how many days we're buying coffee. So X is the number of days, or the number of days we buy coffee, and Y is the amount of money we have. So then we have our equation. Well, we started with $100, and now we're spending $5 per day. So our starting value is 100, and if we're spending, that means we're losing money. So I'm going to put, we're subtracting $5 each day. Well, remember our days was our X, so $5 per day, right? 5 per X could be written as 5X. So our equation is Y equals 100 minus 5X. You could flip it around and you could write Y equals negative 5X plus 100. That would be okay. So what's the domain? Well, remember that's our number of days. Well, when we're talking about the number of days we buy coffee, we're either buying a coffee that day or we're not, right? So talking about half of a day doesn't really make sense because if it's half of a day, I'm not going to buy half of a coffee. So it's either we bought coffee that day or we didn't. So we're going to think about this as it's discrete. So I could buy 0 coffees. I could buy 1 coffee. I could buy 2 coffees. And then do we have a limit? Well, I only have $100. So I can only buy coffee until I spend my $100. Well, let's see, 100 divided by 5 would be 20. So that tells me I can buy a maximum of 20 coffees. So now our range is our money. Well, my lowest amount of money for this is 0. Right? If I spend it all, I have $0 left. And then I'm spending it in increments of 5. So I could have $5 left or $10 left, all the way up to $95 or $100 if I don't buy any coffee. Now we can create a table of values. Notice how similar our table of values is to our domain and range. Right? If we buy 0 coffees, we have $100. If we buy 1 coffee, we have $95. If we buy 2 coffees, we have $90. 3 coffees would be $85. 4 coffees would be $80. And notice how we just subtract 5 each time, right? Because that's what we're doing when we're buying a coffee, is we are spending $5. Well, now I'm going to zoom in on my graph. Remember, I want to label it. So I want to say, I'm going to say money spent on coffee for my title, because that's what we're talking about. I'll put per day. Per day. So X is my number of days I buy coffee. And then we said Y was our money. Okay. Well, again, it makes sense to go by 1. I buy 1 coffee, 2 coffees, 3 coffees. And then I'm just not writing every number to save time right now. Notice that my graph only went up to 15, but I know that my cap is at 20, so I really want to be able to fit all 20 on here. So I'm actually going to adjust this, and instead of counting by 1s, I'm going to count by 2s. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go. And then my coffees, right, I have $100 to start, so I'm going to count by 10s here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I didn't count by 5s because that would not fit all the way on my graph. So that's why I chose 10s. And now we can graph our points. So we started, if we buy 0 coffees, we have $100. If we buy 1 coffee, we'd have $95. So I'm just going to estimate where that is. That'd be kind of in the middle of my square. 2 coffees is $90. 3 coffees is $85. And I'm just going to follow this pattern to fill out the rest of my graph. Now, remember we said this was discrete because you either buy a coffee that day or you don't. Right? Buying like half a coffee or 3/4 of a coffee or like 16 1/3 of a coffee, that doesn't make any sense. So we're not going to connect our points because these are discrete values. They're separate. Right? The numbers in between our dots don't have any value or they don't make sense for our situation. So those are our real world situations. So important things to remember are that when we're looking at our slope-intercept form, when you're trying to write your equation, B is your starting value, so think about where your situation is starting. M is your rate of change. Think about how your situation is changing.